This video presentation is produced by the Emission Measurement Technical Information Center, or EMTIC, and is intended to provide a brief overview of EPA Method 25, the measurement of total gaseous non-methane organic material. Topics covered are background to the method development, sample collection, recovery, analysis, and applicability. Method 25 is published in Appendix A, Part 60, in the Code of Federal Regulations. This video is not intended to provide the details necessary to conduct a Method 25 source test. The EPA is developing QA procedures that will be in Volume 3 of the Quality Assurance Handbook for Air Pollution Measurement Systems, EPA Document Number 600/4-77-027B. Section 3.17 will contain quality assurance procedures and guidance on conducting a Method 25 source test. Copies of the handbook can be obtained by contacting the Office of Research and Development Publication Office, USEPA, 26 West Martin Luther King Drive, Cincinnati, Ohio, 45268. The phone number is area 513-569-7562. In 1977, the EPA wanted to require that VOC control devices at automobile plants operate at a specified efficiency and needed a test method to measure inlet and outlet concentrations of volatile organic compounds, or VOC. For the purposes of this discussion, the term VOC refers to total gaseous non-methane organic compounds. In general, emissions from VOC sources typically consist of mixtures of organic compounds, and there is presently no VOC detection technique producing a consistent quantitative response to all mixtures. Several detection techniques respond to organic compounds. However, the response can vary widely from compound to compound and therefore may not be proportional to the total organic mass or volume in the mixture. Such is the case for the flame ionization detector, or FID, the most commonly used detector for the measurement of organic compounds. The response of the FID to VOC should increase in a linear fashion with the number of carbon atoms. That is why the FID is known as a carbon counter. But the FID response can vary from compound to compound because of other factors, including the types of chemical bonds between atoms and the elements other than carbon present in the organic molecules. For example, the table presented here contains some experimentally derived response factors for FIDs. These figures should not be considered as absolute values because in practice, response factors vary with many parameters, including the type of FID being used. If we assign propane an FID response of 3, then hexane has a response of 6, as predicted by the number of carbons. But notice that the presence of oxygen in the molecule reduces the FID response for methanol, methyl tertiary butyl ether, and formaldehyde. The actual response is less than the theoretical and is 0.75, 4.2, and 0. The presence of chlorine in an organic molecule has a similar depressive effect. In summary, the FID, as well as other types of gaseous organic analyzers, has a variable response to different organic molecules. The response generally increases with the number of carbon atoms in a molecule, but some atoms, such as oxygen and chlorine, depress the response. Method 25 was developed to eliminate this variable response. A brief description of Method 25 follows. During Method 25 sampling, the sample gas is extracted from the stack through a heated probe, a heated out-of-stack filter, and a dry ice condensate trap, and collected in an evacuated sample tank. The method was modified in 1988 to, among other things, incorporate an out-of-stack filter to remove organic particulate matter that can interfere with the analysis. The filter is maintained at a constant temperature of 250 degrees Fahrenheit, plus or minus 5 degrees. The filter catch is discarded. The condensate trap, or cold trap, consists of 3/8-inch stainless steel tubing bent into a U shape, packed with a quartz wool, and submerged in dry ice. This cold trap is also the result of the 1988 revisions to Method 25 and is easier to manufacture than the original and more efficient. The specification for the sample tank has not been changed. Either a stainless steel or an aluminum tank with a minimum volume of 4 liters is appropriate. The sampling probe with a 90-degree nozzle is positioned in the stack such that the probe is perpendicular to the stack axis and the nozzle opening faces away from the direction of gas flow. The probe is heated to 265 degrees Fahrenheit and the filter to 250 degrees Fahrenheit, and the sample is collected. After collection, the sample tank is taken to a laboratory for recovery and analysis. To recover the sample, the condensate trap and sample tank are shipped to the lab after sample collection is completed. The trap will contain frozen water, condensed organic material, and a small volume of sampled gas. This gas may contain a significant amount of CO2, which must be removed from the condensate trap before the sample is recovered, or the CO2 will be counted as VOC. The condensate trap is purged with zero air, and the purged gas is collected in the original sample tank. The zero air purge continues until the carbon dioxide concentration of the trap effluent is less than 5 ppm. After the purge, the sample tank is pressurized with zero air to approximately 1,060 millimeters of mercury. A second evacuated sample tank, known as the Intermediate Collection Vessel, or ICV, is used to recover the condensed organic material in the cold trap. The sample is passed through an oxidation catalyst which converts the organic material to CO2. The procedure for recovering the condensed organics is as follows. The cold trap is removed from the dry ice and allowed to warm to ambient temperatures. While the trap is warming, the trap is purged with zero air. The purged gases are passed through the oxidation catalyst, converting the VOC to CO2, and are collected in the second sample tank. The trap is then heated to 200 degrees centigrade, and the purged gas is also collected in the second tank. This tank is also pressurized. Note that any CO2 trapped in the frozen water in the cold trap during sampling and not purged into the first sample tank will be measured as VOC. Therefore, stacked gases with high amounts of water vapor and CO2 can give a positive bias. In addition, analysis of blank sample runs have produced results that are relatively high and variable. This accounts for the high minimum detectable, which is 50 ppm as carbon. In summary, the tester now has 2 sample tanks to analyze for VOC. The sample in the first tank, collected at the test site, contains non-condensable VOC. The sample in the second tank represents the condensable VOC, which have been converted to CO2. The analysis of the non-methane organic compounds is done as follows. A gas sample from the first sample tank is injected into a gas chromatographic column, which separates the VOC from other gases, including CO, CO2, and methane. A catalyst oxidizes the VOC to CO2. Another catalyst reduces the CO2 to methane. The methane is measured by an FID. Because the sample gas contains only a single organic compound, methane, any FID response factor differences have been eliminated. The sample from the second tank is analyzed in a similar manner with one difference. Remember, all of the condensable VOC were oxidized to CO2 and collected in this tank. Therefore, the CO2 peak from this tank should be measured and counted as VOC. The total concentration of VOC is the sum of both analyses. The units are parts per million as carbon, or parts per million carbon equivalent. Now for a short quiz. 1. True or false? The concentrations of specific compounds cannot be determined with Method 25. True. Method 25 measures total VOC only. 2. A method 25 sample consists of two fractions. True. The condensate trap collects the condensable materials, and the evacuated sample tank collects the more volatile compounds. Each of these is analyzed separately, and the results are added together. 3. All CO2 that remains in the cold trap after sampling is ultimately counted as VOC. False. Most of the CO2 in the cold trap is purged with zero air and collected in the first sample tank. Only the CO2 that is trapped in the ice and therefore not purged into the first sample tank will be counted as VOC. This is why samples with high concentrations of water and CO2 have the greatest potential for a positive bias. 4. Method 25 results must be divided by 6 to express the concentration as hexane. True. Method 25 results are as carbon, and hexane has 6 carbons. Therefore, method 25 results must be divided by 6 for the concentration to be expressed as hexane. 5. Method 25 should never be used to measure mass emissions because the method measures only carbon. Typically, the EPA does not recommend method 25 for the measurement of mass emissions. Method 25 results will underestimate mass emissions of VOC because molecules containing elements other than carbon, such as chlorine or oxygen, have molecular weights greater than corresponding carbon-hydrogen compounds. But if the tester knows the composition of the gas, then the final results can be corrected to actual mass emission rates mathematically. Therefore, the correct answer to question 5 is false. Often there are questions about when to use method 25. When an EPA regulation specifies a method, it is usually not appropriate to substitute other methods such as method 25A for method 25. Following is a list of the regulations currently specifying method 25. Subpart EE, surface coating of metal furniture. Subpart MM, automobile and light-duty truck surface coating operations. Subpart RR, pressure-sensitive tape and label surface coating operations. Subpart SS, industrial surface coating, large appliances. Subpart TT, metal coil surface coating. Subpart WW, beverage can surface coating industry. Subpart BBB, rubber tire manufacturing. And Subpart SSS, magnetic tape coating facilities. Otherwise, in general, for an unknown mixture of VOC, use method 25 when a total VOC measurement is needed. For a known mixture of VOC, method 25 or method 25A may be used. If quantifications of specific compounds is desired, consider using EPA method 18 entitled Measurement of Gaseous Organic Compound Emissions by Gas Chromatography. The last section of this presentation deals with commonly asked questions about method 25. What are the differences between method 25 and method 25A? Method 25A uses direct FID measurement of the sample. Therefore, method 25A analysis of the inlet and outlet VOC concentrations cannot be compared because the mixture of organic compounds in the outlet may differ from the organic compounds in the inlet. Method 25A provides an instantaneous analysis, whereas method 25 samples must be analyzed in a laboratory. Can the Byron system be used to replace the equipment that is specified? Yes, but all procedures required in Method 25, such as the quality assurance procedures, still apply. For what tests are Method 25 audit samples available? Audit samples are only available for a performance test as required by New Source Performance Standards, or NSPS. This concludes our video presentation of Method 25. If more information is needed, or if copies of this videotape are desired, contact the Emission Measurement Technical Information Center.